Okay, so our three variables are co-integrated, so we can easily run the vector error correction model, and that we shall do now. So I go to quick estimate var, then I write the variables. So the first one will be the literature because that is our dependent variable, literature, and then GDP, then investment, right? And here I choose vector error correction model, and exogenous is our dummy variable, right? And here what is our target? Our target, whether the dummy variable has a positive impact on the literature or not, that we want to check today. That means whether welfare state has a positive impact on the rate of literature or not, that we want to check today. And we have chosen here, we have chosen lag 1 because our target is to develop an error correction model. So I choose lag 1. You see, I have chosen lag 1, right? I have chosen lag 1, and yes, everything all right. Setting is all right. Now I check co-integration, right? I check here. Okay, and how many co-integration? Last time we saw we saw one co-integration. Last time in the Johansen test of co-integration, we saw there are one co-integrating equation. So here I write 1. Actually 1 is already given there, so I do not need to write 1 because it is already given. Then I choose number 3, right? Okay, then I run the model. Oh, sorry. Later, I think I have done a, okay, I run it again. I think I have done some mistake here. Oh, sorry, it is not literature. I run again. Estimate var vector should be literacy, not literature. Literacy, GDP, investment, right? So these are the three endogenous variable. And number of lags, suppose I choose 1 lag, and exogenous is our dummy variable. Literacy, yes, we can check from here, literacy. So I put the literacy first because the literacy will be dependent variable. So, and I choose vector error correction model, and co-integration I choose 1, right, because we got 1, and I choose 3, right. Then I run the vector error correction model. Yes, this is my vector error correction model, and you can see the co-integration equation. Here the dependent variable is literacy, and this one is the co-integrated equation, and this is the error correction model, right, having lag 1, right. Okay, this one is the coefficient, this one is the standard error, this one is the t value, but here is no p-value. You can see there is no p-value. Also here it is coefficient, it is standard error, and it is t-value. But my target is to know the p-value. So how to know the p-value? So I go to edit, I go to proc, I go to make system, and I go to order by variable, right? So well, we can see our three model. That is the model number 1, and it is model number 2, and it is the model number 3, right? So we call it system model, system equation. You see it starts from C1 until C18, right? And here, from here to here, actually from here to here until this, actually we call it co-integrated equation, right? And what we shall do, we shall be taking residual from here. We shall be taking residual from here, and that will be used as a error correction term. We take the residual from this equation, and that will be used as a error correction term. Okay, so we need this one. We need only this one. So I take it, I copy, and I go to quick. Then I choose estimate equation. Then I paste it. I paste the whole things here, right? So I press OK. So this is my error correction model, where literacy is the dependent variable. You know, the VECM model automatically make the variable into first difference all the time. You see, last time we put the only the literacy, but VECM model converted it into first difference. You can see from here there is a D, right? First difference they have converted. Why? Because when it become first difference, the data will be stationary, and that is why they convert it to first difference to make the data stationary. Because normally time series model need stationary data. Okay, this is our model, error correction model, and this is the dependent variable, and C1 is the coefficient of the error correction term, right? You can see from here, right, from here to here until this C2, C1, which is this one, right? C1 means this one and this one. So this one is the error correction term. And what is C2? And C2 is this one. You can see from here. C2 is the actually this one, the coefficient of the literacy. And C6 is the coefficient of dummy variable, right? That is C6. Okay. And okay, now we check one by one. C1, the error correction term is significant. You can see from here, significant, and the coefficient is negative, right? There are two things are here. One is the error term is significant plus negative. It means that that there is a validity of the long run associationship among all the variables, right? So I'm telling again, when the error correction term is significant and negative, it means that there is a validity of long run equilibrium associationship among the variables. So we are happy that all the variables have long run associationship because error correction term is significant and negative. What about C3? What is C3? C3 is the GDP, right? This one. C3, is it significant? No. That means GDP does not influence the rate of literacy. C4, C4 is not also significant. You can see from here. So, but C5 is the intercept, but the dummy variable is significant. You can see significant. Why? Because the p-value is 3.94% and the dummy variable, the coefficient is positive. So if the dummy variable is significant and if the coefficient is positive, it means that welfare state, which is Maria land, has a positive impact on the rate of literacy in Maria land. I am telling again, if the coefficient is positive and it is already positive, and if it is significant and it is already significant, meaning that the welfare state that Maria has entered has a positive impact on the rate of literacy, meaning that that means the Maria land has taken the right policy by converting the country into welfare state. As a result, it can contribute to the rate of literacy in the Maria land.